Hi children, good morning. How are you? Fine. Okay? Yes. So, in the last class we have completed about the light, reflection, refractions. Is it? Have you watched the videos, children? Very good. So, welcome to today's new topic. That is chapter number 12, electricity and circuits. Electricity and circuits. Okay, so nowadays we are using the electricity commonly. Is it, children? In your house, TV is there, mixer, washing machine, then grinder, bulbs. Is it? These are not how it is working, children. By the electricity. For example, you are watching a interesting movie. The power gone. What you do? Oh, what happened? Oh, you next that hero or heroine or villain, he is going to kill or what it is happening. Now only the current should go. So somewhat you will feel bad tension. Is it? Yes. So we are giving much importance nowadays for the electricity. Not only at home, for the offices, for the schools and so many places we are using. If there is no power, we can't assume like that we have addicted for the electricity. Is it? Okay. Night times. Day times if electricity gone means we will go for play or we are going to engage with any other things. Then what about suddenly you are doing some work at night time, the power gone. What you will do, children? So you are going to search for a candle or you will search for the torchlight. Immediately if the torchlight comes means you will feel very happy that somewhat the light came for you instead of sitting in the darkness. Is it? Torchlight. Or you will say nowadays we are using the charged lights that are nothing but UPS or generators in hospitals or some other schools or factories. We are going to use the generators. Is it? Electric motors. These are all we are going to use it instead of the electricity. Is it? Let me see. What do you mean by the electric circuits? So, path of transmitting the electric current. That means it's the way of transmitting of the electric current. Then electric circuit includes a device that gives energy to the charged particles constituting the current, such as a battery or a generator. Devices that use the current, such as lamps, electric motors or computers. And the connecting wires or the transmission lines. That means instead of that we are going to use the other devices. So now we are going to talking about the torchlight. What it is present in that torchlight, children? That only we call it as the electric cell. What do you call for that? We are going to call it as the electric cell. Then what do you mean by that electric cell? Have you seen, children? What is that electric cell? How it will be? For what purpose we are going to use? For what purpose we are going to use that electric cell? So it will be the outside will be covered with the metallic one and top you can see like this. Is it? Yeah. So this top which we are going to have, it is denoted as the positive and the bottom one will be denoted as the negative one. That means a cell, electric cell is having the two terminals. How many terminals? How many terminals, children? We are having the two terminals. That is positive terminal and negative terminal. For each and every battery, that is the cell, will be having the two terminals. That is, one will be the positive terminal and another will be the negative Where we'll use these cells, children? For the remote and for few toys. Is it? Then other for the torch lights also we are going to use this cells. Is it? Yes. So if you go for the bulb, have you seen the bulb, children? Have you seen the bulb? I can show you the bulb, children. So this is the bulb. So for this also it is having the positive and also as well as negative. So I can show you the terminals. So these are the terminals for the positive and the negative. How many terminals for the bulb? 2 terminals, positive and negative. And also here we can see the cell. For that also we are having the positive and negative. So here for the bulb you can see like this. The filament will be given, children. Have you observed like this inside? So this one we call it as the filament. Here one positive, one negative will be. So 2 terminals and inside for the bulb the filament will be. If the cell is connected to this bulb, so how the cell will be connected? So one will be the positive for the cell and one will be the negative. The positive side will be connected to the positive and the negative will be connected to the negative. So that what will happen? The bulb will glows. Is it? Yes. So if the cell is, the wire is disconnected, if the wire any one side, both sides also, if any one side is also disconnected, means the bulb will not be glow. That means electric cell means it is a source of the electricity. It is the source of electricity. Then an electric cell produces electricity from the chemicals stored inside it. Do one thing, children. If any cell is there with you, if it is finished, that means very good. So if in these chemicals are finished, that means the capacity of that chemical is finished, means once again we are going to replace the another cell. After that just you can observe the parts of that cell. So positive, negative, then remove that outer coating one, that is the metal one. Be careful, children. Then inside you can see a small rod. So like this, a small black color rod will be given. That rod is nothing but for us the chemical. So that is the carbon rod. That rod will be given, and black it will be here. That is the coal particle and mixed with the some of the chemicals. Okay. So we have to observe like that things like that. We have to open and we have to see. I think you are going to see that one. Is it? Yes. So this is about our cell. So today we have learned what do you mean by the electric circuit, what do you mean by the electric cell, how the cell will be and how the bulb will be. And for the bulb, this one we call it as the filament, and for the bulb also will be having the 2 terminals, the positive terminal and the negative terminal. So for this supporting video I am going to show for you. Watch the video and you can get some idea about the cells, about the electricity also. Okay. So let me stop today's session. Tomorrow we'll meet with the new topic. Okay. Watch the video. Thank you. Thank you very much.
Who does not like the rainy season? Especially when hot pakoras are being made at home. Today, Sunaina, her younger brother Sohan, who is 2 years younger than Sunaina, her father and mother, all were at home. Dad was making his favorite potato onion pakoras. Sunaina's mouth was watering on seeing this. Meanwhile, Sohan came shouting, "Didi! Didi!" and pulled her beside the window.
Sister, look at the lightning in the sky.
Seems like it is going to rain very hard.
Suddenly, the electricity of the house went off.
Hey,
Someone come with a torch and help me in the kitchen.
On hearing Dad's voice, Sohan and Sunaina went carefully towards the kitchen. Mother started lighting the torch, but it didn't start.
Mother, show it to me.
Sunaina went out in the light and checked the torch.
Its bulb looks absolutely fine. Let me check the battery.
As soon as Sunaina pulled out both the cells, she noticed that one of them was not installed properly.
Hey, this cell is fixed upside down. Now, let's place it correctly and check.
Sohan was watching all this very carefully. As soon as she fixes the cell, the torch lighted.
Hey, very good. You've turned it on.
Yes, Dad. Its cells were placed in the wrong direction. Now I have fixed them properly. Yesterday we did this experiment in the class.
Well, come. Now you all sit inside and let me bring hot pakoras for everyone.
Sister, please tell me how you have turned on the torch.
Sohan, a torch is a device that is lighted up with the help of an electric cell. Just watch this torch carefully. What does it have?
It has a very small bulb fixed to it that is similar to the big bulb in the room, but a big bulb runs on electricity.
Rightly said, Sohan. Electricity in that bulb passes through wires. These wires are inside or outside the ground or walls. In this torch, electricity comes through the power cell. The electric cell inside this produces electricity. We will learn more about it in the school tomorrow. Then I will teach you in detail about this.
Sure, sister.
Yes, sure.
Meanwhile, Dad brings hot pakoras and everyone eats them with great fervor. The next day, while going to school, Sunaina had many questions in her mind.
The electric switch has current. But where does this current come from? There are so many things in the house that run on the electricity. How do they all work?
When Seema Didi came to class, Sunaina asked all these questions to her. Today we are going to discuss about all of these, Sunaina. It's good that you asked this question. Let's do something interesting today, kids. Seema Didi made groups of 4 children and gave each group a bulb, some electric wires, plastic rubber, and an electric cell. All groups have a bulb, battery, and electric wires. First of all, check the bulb thoroughly and then tell me, what have you seen?
The bulb is made up of glass and there are small wires inside the bulb.
Those wires are called fibers. When we will light the bulbs by experiment, carefully inspect the fibers.
The bottom of the bulb is made up of metal. It is round in shape. Seema Didi, it also has a plus and a minus sign placed on it.
That bulb has 2 terminals. One has a plus sign and one has a minus sign on it. Now we will all learn to turn on the bulb with the help of this battery. You should keep in mind that with the help of this battery, we are producing electricity. Do this experiment in front of elders and only with the help of this battery. Do not repeat such experiments using electrical wire or socket. Now remove the plastic cover or layer from both ends of the electric cables. All of you have been given a plastic rubber. With the help of that, try to light the bulb by connecting the battery, wire, and bulb. All the 5 groups started working. Sunaina's group consists of Sunaina, Mohan, Meena, and Pradeep. Sunaina quickly removes the plastic cover and Mohan puts the plastic rubber on the battery and starts connecting the other ends of the wires to different parts of the bulb. The same process is going on in other groups too.
Let me connect both these ends to the bottom of the bulb.
the bulb does not turns on while doing so.
Look at this. Marks are there, both on battery and bulb. Let's connect the plus sign of the cell with the plus sign of the bulb and the minus sign of the cell with the minus sign of the bulb.
On doing so, the bulb turns on.
Seema Didi, look, the bulb has turned on.
Oh wow! Now let us connect it upside down.
Can we reverse this? Let's connect the plus sign of the cell with the minus sign of the bulb and the minus sign of the cell with the plus sign of the bulb.
Even on doing this, the bulb turns on. All the groups tried to turn on the bulb in their own way, and everyone succeeds. All the children were very happy after the experiment.
Seema Didi, why the bulb has turned on by only few methods?
Good question. Come, let's find out why has this happened. Sunaina, how did the bulbs in your group turn on?
Didi, we connected the plus sign of the cell with the minus sign of the bulb with the help of a wire. This has caused our bulb to turn on.
When all the things, bulbs, wires and batteries are arranged properly, then it makes a way for electricity to pass. This type of arrangement, where both terminals of the power cell are connected to both terminals of the bulb, it is called an electric circuit. The bulb could only be turned on when an electric current flows through the electric circuit you created.
Yes.
Okay, now let's make a flow chart of what we learned today, kids. Seema Didi created a flow chart on the board like this. From electric cells, electricity is generated. Electric current, which flows through electric circuit, through which electric devices operate. All the children made this diagram in their copies.
Today's class was very interesting. I will go home and tell about this to mother, father and Sohan.